Is a single source of truth in marketing a myth or a reality? How many of you believe there can be a single report that is telling you everything you need to know about marketing performance across channel, across campaigns, with a single number you believe? Raise your hand. Ooh, not so many optimists in the room. Let's see. Let's see if at the end of the presentation the answer is going to change. I'm going to ask you again. Marketers, when measuring performance, we basically have three needs. No? We have a need for insight, we have a need for optimization, we have a need related to strategy. Let me tell you a little bit more about it. We, of course, want to look at the performances in the past. We want to make sense of it. We want to understand what happened. We want to draw conclusion. We want to look at the campaigns. We want to look at the channel that work. We want to understand what delivered the ROAS or the ROI for our campaigns. In other words, we want to understand the past. We have, of course, a need for optimization. We work on our campaigns day to day. We need to choose what keywords to bid on, what audiences to invest on. We need to choose what ad is working better than the other. We have a need, in other words, to steer the present. We have a need related to strategy. We need to make choices for the future. We need to decide where to allocate our budgets. We need to decide, which channels, which things we want to play on that are going to be important for our campaigns. In other words, we want to plan the future. This sounds really simple, doesn't it? Wrong. So marketing measurement was always hard. It's always been difficult. Yeah. So this is nothing new. And we all know why. I just want to remind you why. The main idea is that customer journeys are really complex. They involve multiple devices. You can watch ads on your television. You can watch ads on your desktop computer. You can watch ads on your mobile smartphone. Yeah. And measuring all of those changes of touch points within different journeys on different devices has always been really complex. There are also different touch points of different nature. Yeah, you can view the ads, you can click on an ad, but you can also interact with an ad. You can engage with an ad, especially if it's a social media post ad. And then, last but not least, you have this problem that you only always have one piece of the puzzle or a few pieces of the puzzle, but you don't see the full picture because you have the walled gardens. Yeah? Many of the vendors you work with, many of the ad platforms, they don't share all the data with you. So you don't have access to everything. So you only have a partial view of what is happening. Top of that, there's a heavy reliance on cookies and last click attribution. Yeah, many of us still use last click attribution, right? I'm pretty sure that some of us in the audience still do. Yeah. It's highly inaccurate, leads to costly budget misallocation, and it can erode your marketing performance. What happens then? Yeah, the problem is that you typically tend to overinvest in retargeting, underinvest in prospecting. You tend to overinvest in the bottom of funnel and underinvest in the top of funnel. Yeah, that's what happens most of the time when you're data-driven. When you're looking only at the data you see because you don't have the full picture. But this is not it. There's more to the story than that. It's only going to get worse. We are getting into a privacy-first world, and third-party cookies are going away. Should have been in 2024. It's going to now be 2025. Who knows? Maybe. 75% of users will opt out from app tracking. iOS 14 has been a huge issue for a lot of the advertisers. You don't see the data. You can't track the conversions to the endpoint. And there's going to be unknown returns for 600 billion of digital ad spending per year. It's pretty scary, right? On top, yeah, Meta and Google AI bidding systems are taking over. Yeah, it's more and more difficult to understand what is going on. Most of these bidding systems, they are for us a black box. We don't know exactly how they work. We only see the performances at the end. Can we really trust them? Yes, no. What is happening underneath? We don't have access to the full picture here. It's a big challenge, but hopefully, what we want to communicate today is that it's also an opportunity. It's an opportunity for us to get measurement in place, like it should be. So let's get started. There's a few things we want to do with you. We want to introduce you to the three main measurement methodologies. We want to highlight advantages and disadvantages of each standalone methodology. We will present the concepts of triangulation. We will give you tips, actual tips, even libraries to look at for each one of the different methodologies, so you can get started on your own. And then we will leave time for the Q&A. Sounds good? But before we start, I wanted to say something, maybe a couple of words about ourselves. It's a very special moment, for many reasons for me. I started my career in Germany, and coming back here to Germany is a country that I really appreciate. It gave me the best opportunities of my life. But the second thing I wanted to say is that I started my career many years ago in a company called Delta Method, which was a company creating a software solution to scale performance marketing campaigns, specifically search engine marketing, to millions of keywords and ads for large advertisers. Then I progressed. I became a chief marketing officer, a chief growth officer. I went into venture capital, entrepreneurship, done a bunch of things, but that's not important. The important thing is that that company, Delta Method, was acquired by Crealytics, my partner today for this conversation and masterclass on triangulation. So it's one of those full circle moments where I get to get back to my origins, and I'm very thankful for Crealytics to invite me and to give me the opportunity to go full circle on the things of my life. But especially, it's an honor for me to do this alongside with Stephen Owe, head of data science at Crealytics, who's an incredibly smart guy. Please say a couple of words about yourself.
Thanks a lot, Enrico. Yeah, I have a scientific background. I studied chemistry many years ago. 6 years ago, sort of found my way to Crealytics, and since then I've been trying to use this idea of scientific rigor in digital marketing measurement at Crealytics. An interesting challenge for sure. And I'm very excited today to talk about three of our core methodologies that we use to try and do that, to try and inject scientific rigor into digital marketing measurement. And I'm very honored to speak with Enrico, who has depths of industry experience in applying these techniques in lots of businesses.
Thank you, Stephen. So in other words, he's the smart guy, so when we get to the Q&A, the hard questions to him and the simple ones to me. Do we have a deal? Sounds good.
I'll do my best.
All right. Okay, so now we can get started. So there are basically three methodologies for measurement, which are prevalent nowadays. Number one is lift testing. This is incrementality testing. It's a way for you to understand the incrementality value of your campaigns. What are the conversions that I get that I wouldn't get anyway if I didn't do advertising, It's a way for you to establish causal relationship between the marketing spend and your final results. It's a very, very powerful technique. The second technique is marketing mix modeling. It's a regression technique that allows you to link your inputs, your marketing pressure, measured by either media spend, impressions, or clicks, or whatever you choose, to the final output, perhaps sales. Yeah. This is a top-down approach. Yeah? It doesn't take into consideration user-level data. You're just linking your inputs with your output by means of correlation. The last approach is multi-touch attribution. Multi-touch attribution gives you granularity. It's the most prevalent approach nowadays. You take user-level data, you check the different touch points that take a user from being a visitor to finally being a converter and a customer, and then you give credit to each of those touch points by aggregating them. Yeah? So it's a very different technique from MMM, but an equally valid technique. Now, all of these measurements, if you ask the same question to each of them, you're going to get a different answer. And that's a problem because, you know it. You look at your platform data, you look at your Google Analytics data, you see completely different numbers there. Same thing happen here. If you use the three methodologies, you're going to get three different numbers because each one of which they have advantages and disadvantages. Yeah. So on their own, they're going to give you different answers to your question. And your stakeholders, of course, are going to be puzzled and frustrated because they don't know what's the real ROI of your marketing campaigns. Let's look at the advantages and disadvantages. So lift testing is statistically accurate. This is the golden standard for the scientist because it actually allows you to establish a counterfactual and understand what's the real incremental value of your campaign. It's privacy proof. It establishes causality. Problem is, it's difficult to scale. You can do one experiment at a time. Sometimes it's difficult to set up one experiment. You need time, and there's especially an opportunity cost because it requires you to hold out some marketing budget from your campaigns, which means you're not advertising, you're not generating potential ROI. So there's a huge opportunity cost attached to it. The second one is marketing mix modeling, which is amazing because it's holistic. It doesn't take into consideration only your marketing campaigns and your marketing spend, but it also takes into consideration other important factors, such as seasonality, discounts, pricing, you name it. Anything you can quantify on a weekly basis, you can put it inside your marketing mix model. Because you know that it's not only your marketing ads that are generating sales, but it's also a lot of other factors. It's privacy proof because you don't look at user level data, but it also has limited granularity. Let's remember, it's based on correlation. So only the things you can actually detect that have an impact on your top line are going to be detected by a marketing mix model. It requires long history because if you want to understand your seasonality, if you want to understand how things progress and how do they actually impact your top line, you need enough history to establish statistically accurate results. And it's also sometimes difficult to implement. You need tech competence, you need to understand, you have a basic understanding of statistics. Yeah, many reasons why it's not that straightforward. MTA, on the other hand, it's real time. You can get data right away, which is super important if you want to steer the present. Remember what we said at the beginning of the presentation. You get user level insights, which is also great. And it's easy to implement, mostly because many of the platforms you use every day, they already have a built-in models for that. But it misses offline marketing data. You can only check, visits when you have a UTM parameter attached. So things such as TV, radio, and other things you do offline, they are not seen at all by MTA. And of course, it's reliant on cookies. Yeah, and in a privacy-first world, it's harder and harder to get this right. Okay, so what's the solution to that? The solution is the idea of triangulation. The idea is simple. You need the three of things, the three methodologies working together in orchestration. Here's the idea. You take the incrementality test results, the results of your experiment, you inject those results into marketing mix modeling for calibration. Marketing mix modeling is going to be your absolute framework to understand the value of your campaigns. But remember, it's only high level. And then what you do, you attach your multi-touch attribution results underneath on a relative basis. So then you have a full picture that goes from the very, very top level to the detail level. This gives you a methodology which is always on, which is what you need to steer campaigns on a day-to-day basis. It's accurate and precise to the extent to which your data is also good data. And then it's future-proof because it doesn't rely on cookies that much. What we're going to do now is that we're going to spend roughly 15 minutes each on the methodologies. We're going to go practical. We're going to give you an example of each. Because anyway, you have to go through each one of them in order to be able to build triangulation. At the end, we'll spend the last 15 minutes giving you the step-by-step instruction on how to do the actual triangulation. Does that sound good? Okay, so you have to bear with us until the very end to get, to get the step-by-step instructions for triangulation. Okay, first in line, lift testing. This is his favorite methodologies because he's a scientist. It's a golden standard of establishing causal impact of marketing campaigns. The idea is that the randomized control tests are actually the best way you do it. The way you do it is you try to think about your target audience you want to expose your ads to, and you divide it into two groups. Randomly sampled. Yeah, that's very important. On the first group, you're going to expose it to ads. The second group, you're not going to expose it to ads at all. Then what you do is you check at the end, you evaluate the difference between the two. The difference between the two is the incremental impact that you add, your marketing spend, and that channel add on your total revenues. Of course, this requires you to be able to split your audiences in two parts, which nowadays is not that easy, right? You can still do it in email marketing, for example, because you have control on your database. You can still do it in Google and Meta as long as you get in touch with your account representative, and they allow you to do a lift test. But not so many channels allow you to do that. So you have other approaches that you can take. You have sequential testing, which is pre-post treatment. You basically start with a week of no advertising, followed by a week of heavy advertising, and then you check the difference between the baseline. This is very common in television because television doesn't allow you to split your audiences in different geographies or split your audiences on a user level basis. Geo-based testing is very, very common approach nowadays. You divide your geographies into geographies which are highly correlated with each other, and then you check the incrementality between each. And the last one is A/B testing. But A/B testing is tricky because A/B testing is not an absolute incrementality approach. It doesn't allow you to check incrementality of a given channel. It allows you to check relative incrementality between one version of a campaign with another. When it comes to MMM, it's probably interesting, for example, for control factors such as promotions, because you can, for example, understand what's the incremental impact of a promotion versus an ad without. Yeah? So you can still use A/B testing, but it's not a pure incremental approach. Now, Stephen is going to take us through the geo-based testing approach.
Thanks, Enrico. So yeah, at Careerlytics, we favor the geo-based testing approach. These are called geo experiments. Why do we favor those? They are a great approximation of that golden standard that Enrico mentioned, which is the random controlled trial. And instead of doing users as your test units, instead we're using geolocations to approximate those as test units. So we are approximating a random controlled trial with a geo experiment and then using something called counterfactual prediction to compare against a control. And I'll talk about that in a sec. Let's go to the next slide and look at a simplified example. So let's say we want to understand the true ROAS of our meta ads investment. We are going to plan a geo experiment to check that. Google Analytics is our source of truth at the moment. And Google Analytics, so we spend 10K per month in our main market, which is the US. Google Analytics is attributing maybe 20K revenue to our meta ads investment, which gives us a 2.0 attributed ROAS. But I don't know if that's correct. We want to verify that with a geo experiment. And importantly, we are not going to measure the impact of that experiment on attributed revenue. We're going to measure the impact on our total recorded revenue in our market because we want to be analogous to the attribution, and we want to verify whether the attribution is correct because we suspect that it's being underreported in Google Analytics. So first things first, we need to do our experiment design. This is the first phase of any test. And in a geo experiment, that means selecting your geolocations, selecting your sample that's going to be in your test. And we're doing here a holdout experiment. So that means we're going to be pausing our ads in certain geolocations and comparing that performance against a group of control locations, which represents our test locations. So we've decided for this test that we're going to do a holdout in 10% of our market. And here we're using US states as our geolocations. So that means we're going to be pausing ads in 10% of our market, where we spend 1K per month. And importantly, we should receive 100K per month revenue overall. So that's non-attributed. The second step is to find a group of control locations that represent those test locations very closely. So in this case, they match by volume, but more importantly is that they're very correlated over time. Let's talk about why that is important. So it's so important that these locations are correlated in terms of performance over time because we're going to be doing a statistical technique called counterfactual prediction to make our control for this experiment. So the idea is when we turn off the ads for perhaps 1 month in our test locations, we're going to track the performance in our group of control locations and use that performance to predict what should have happened in our test locations if we hadn't paused those ads. And that is called a counterfactual. And this technique is at the heart of most incrementality testing approaches. In fact, most of the open source libraries that we use to plan and design and evaluate these tests have this concept at the heart of them, and that is counterfactual prediction. So Meta uses GeoLift to do that, and Google uses trimmed match, and we've used both of those in the past. But currently we're favoring Meta GeoLift, which I'll talk about in a minute. So the second phase of our test is actually doing the treatment. So we've planned our experiment now. we know which locations we're going to turn off, and we know which ones represent that as a control. So we are going to start our pausing of ads, and we're going to do that for 1 month. And so we've spent $0 in that month because we've paused our ads in those locations. Makes sense. Interestingly, we recorded only 97K total revenue in those locations in that month, whereas in the control, we recorded 100K, which is what we usually get in those locations. So our counterfactual is saying 100K, our test observed revenue is 97K. That means we have a 3K deficit from turning off those meta ad investment. That means we lost 3K by doing this test. This is actually a good thing. It's what we want to happen. It means Meta is incremental. It's causing revenue. Not only that, Meta is actually more incremental than it was being given by Google Analytics. It's 50% more incremental because the ROAS is now 3 rather than 2, which is what Google Analytics was attributing. So what can you do with that information after you've run a test? So we have this factor of a 50% increase against our attribution system, and this is phase 3, which is our evaluation, and we've scaled that up to the market now. So we're extrapolating from our test sample up to the market level, so we can now apply these insights at the market level. So the ROAS stays at 3, and we think we get 30K revenue from our meta ads investment every month. That is 50% more than we previously thought. So we might use that information now to move budget from perhaps less incremental channels into meta ads to increase our overall profitability of our marketing portfolio. And that's generally the idea of doing lift tests on your biggest channels, is to get these kind of insights and to check against your other sources of truth, like multi-touch attribution, to see how well they are evaluating your main channels. So that was a simplified example, and something I didn't mention there is sort of how we identify these test and control regions. So you need to decide as part of your experiment design, what is your sample size? How many ads are you going to pause? How many users are you not going to allow to see your ads? There's 2 extremes here, so you need to balance the idea of the risk involved with this test, because we will lose some revenue by turning off some ads if the channel is incremental. You need to balance that risk with statistical sensitivity. So you want to get a significant result from your test as well. So there's 2 sort of extremes here. We could go too hot. If we turn off our ads across half of our market, we're going to lose half of our incremental value in that month, which is quite a lot of money often, especially if that channel is very incremental. The other extreme is we could go too cold, and we would only turn off a few small locations because we're trying to be risk averse. Unfortunately, that could lead to not getting a good signal to noise ratio. So instead, the difference between the test and control could then be due to sort of random fluctuations in this noisy digital marketing landscape. There's lots of variables at play, lots of random fluctuation, so we need to create a big impact to get a good signal to noise ratio. And unfortunately, if you do it in too small a number of locations, you will likely not get a significant result from your test. So you have to balance these 2 things, and this is a crucial part of designing a geo experiment or another kind of incrementality test. So here's how we actually do that for our clients at Triangulation. We use GeoLift, this open source library that I spoke about before, to calculate some statistics for hundreds of different possible test designs. So we use this library to go through hundreds of different combinations of US states, for example, and generate lots of controls for those. And that will produce some statistics, one of which is the market holdout share, so how much of your market revenue you are putting at risk. And the other one is this idea of a minimum detectable effect. So we do a power analysis, which is a common technique for any kind of experiment, from that golden standard random controlled trial, geo experiments, or A/B tests. You can do power analysis for all of those, and that will tell you what your minimum detectable effective is for a given sample size. So we have 2 options here. For example, design option 1 would involve turning off 25% of our market. That's quite a lot of risk to take on. So you're risking 25% of that channel's incremental revenue for that month, for example. And that design option would allow us to detect a channel that contributed 4% of our overall revenue. So that's quite sensitive. Because we've turned off more of our market, we can create a bigger impact and get a better signal to noise ratio, and we're able to detect any channel that contributes at least 4% of our business's online revenue. Option 2 here is a much more risk-averse option and might only be suitable for larger channels. So we have a 6% holdout in our market, but it only allows us to measure large channels that contribute at least 8% of our market revenue. So there's a real balance here between the risk involved in a test, the size of the channel that you're testing, and the sensitivity that you can get with those tests. And I mentioned we use this package called GeoLift, which is created by Meta to do this, and I'll speak a bit more about your options if you want to do your own geo experiments and if you want to do this in-house on the next slide. So how can you get started with running your own lift tests? You should definitely use an open source package. Do not reinvent the wheel. This stuff has been done before by lots of people, and there are well-known and well-used packages out there that can give you a real head start to doing this kind of technique. So the one I've mentioned and the one we use is Meta's GeoLift package here on the left. So we think of this as industry best practice. I find the library very user-friendly to use. It has lots and lots of in-depth choices from the design phase to the evaluation phase, all built into the package, and it uses this really cool methodology called synthetic controls to generate that counterfactual, that synthetic control that you'll compare with when you do the test. Google have an alternative to this called trimmed match. I don't find trimmed match quite as user-friendly as GeoLift, but we have used it in the past. It is very well researched and used by lots of advertisers. It doesn't use synthetic controls. Instead, what it does is pair individual geolocations together to create the matching control group. I don't think that's quite as flexible as synthetic controls, which I'll speak about in a second. But if that does sound interesting to you, and you perhaps don't have the data science resource to plan these tests and use these open source libraries, because it does involve some coding, then what you might be interested in is this new beta that Google have introduced to the Google Ads user interface, which is the Google Ads Geo Conversion Lift. So they basically wrapped trimmed match in a front end now, and you can access that in Google Ads yourself, and you can basically go in there with a user interface to design a GeoLift experiment inside Google Ads. It's based on trimmed match, so it's just a front end for that library, and it's very user-friendly because it doesn't involve any coding. However, you will be limited to metrics like Google tracked pixel conversions or Google tracked conversion value, whereas if you roll your own test with the open source libraries, you could measure the impact on whichever KPI you like, as long as you can track at the geo level. So there's some pros and cons to each option, but these are some great options for you to get started if you want to roll your own incrementality test. I said that I would mention synthetic controls. I think they're a really cool, quite modern methodology for doing counterfactual prediction, and these lie at the heart of Meta's GeoLift library. So GeoLift is based on this package called Synth, which is an R package for doing synthetic controls. And how it works is basically, instead of the trimmed match approach of pairing each geo with another geolocation, synthetic controls actually use a weighted average of many, many locations to construct the control group. So if we're doing our test on these 3 states here at the bottom, obviously we're pausing ads in the entirety of those states. What synthetic controls will go and do is look for many, many states that represent our test states, and it will apply a weight to each one. So that's what this represents here at the top. We have 4 different states. In reality, it would probably be a lot more. And each one has an individual weight, and you can take shares of different states' performance over the history to most accurately represent the group of states where you're actually pausing ads, and that can get you a really accurate counterfactual, a really accurate synthetic control, which can boost your signal to noise ratio and give you a really good sensitivity for these tests against other methods. So in this case, you would have maybe 1 million revenue recorded in your synthetic control, your weighted average, and then by pausing ads, you've only tracked 900K revenue in your test locations. That would mean whichever channel you paused provide an incremental value of 100K in this example. Let's look at a real-life example that we did at Crealytics with one of our clients. This was a test we did on Meta Ads, And I think it's a cool result because it uncovers this idea of a low funnel bias in lots of multi-touch attribution models. So we did a split test inside Meta Ads, one on the acquisition campaign segment and one on the remarketing or retargeting campaign segment within Meta Ads. So we did a sort of dual geolift experiment, and we found some really interesting results. As we kind of expected, acquisition campaigns are much undervalued by multi-touch attribution, even Google Analytics. So we got almost 3 times the incrementality on our acquisition campaigns. And as we expected, we got a lower remarketing incrementality compared to what Google Analytics was saying. And what the client was able to do with this information was then perhaps shift budget from their remarketing share of Meta Ads more towards their acquisition share of campaigns, because they now had this new information that the acquisition campaigns were so much more incremental than they'd previously thought, given their multi-touch attribution results. So Enrico and I, for each of these sections, have worked to put together some insights, some key learnings from our experience in the industry of running, in this case, lots of incrementality tests. So as we just saw, prospecting tends to be highly undervalued by multi-touch attribution. There is a low funnel bias, so retargeting tends to be overvalued. Brand keywords is another classic example of a geo experiment request that we get from our clients. It doesn't logically make much sense that brand bidding would be incremental if your organic link is already at the top of the search engine page. And we see that when we run these tests. So often, unless the client has a very strong reseller competitive landscape on the search engine results page, there's not much incrementality to bidding on a brand keyword if your organic results are already there. And finally, incrementality tests are the best approach mainly for your larger channels, which make the biggest impact to your business. I've talked a lot about signal to noise ratio. It's quite difficult to get a good signal to noise ratio for smaller channels or individual campaigns with this technique. So this is really a technique that can be used for your largest channels, which are making the biggest impact to your business, and will give you the best insights because you can then compare how those large channels are performing in the test results versus your source of truth, which might be multi-touch attribution. So you get some great insights from running 2 to 3 incrementality tests on your biggest channels. Yeah.
Thank you, Stephen. So now we have one methodology down. You still have the energy to go through other 2? Almost. Yeah, it's going to take a lot of energy. Okay. Next in line is marketing mix modeling. My favorite technique. Marketing mix modeling is a regression technique that allows you to understand the link between your inputs, your marketing pressure, and your final sales, or whatever is the objective you're optimizing for. How does it work? It's a holistic attribution model. As you know, consumers are influenced by a lot of different factors. Not only, of course, marketing spend, but you have seasonality, you have promotions, you have pricing, you might have, digital media, offline media. You have also your competitor activities. The competitor activities and the level of aggressiveness on competitor campaigns also changes your performances. All of these things, you can quantify them. And if you can quantify them, they can be part of your marketing mix model. Yeah. The idea of a marketing mix model is you're trying to take your inputs, you're looking at how they move, and you see how they move along with your top sales. The stronger the movement, the co-movement and the correlation, the stronger the signal that marketing pressure is delivering sales results. Now I'm going to take you for a moment back to school. Are you ready? Okay, let's go back to school for a moment. That's a scary equation here. It's a simple regression equation, where we are looking into a dependent variable, which is our y, and we are linking it to multiple factors, our x's and z's. Here's the idea. Your target variable might be what you're looking for, what is important to you, your North Star. It might be revenues, it might be sales, it might be leads, downloads, new customers. It can be anything you want, even brand awareness. You can also model for that if you're interested in the impact on brand of your marketing campaigns. Then you have 3 major components here. You have the baseline. Here pay particular attention because the baseline is super important. It's something you don't have anywhere else. The baseline is telling you what would be the conversion if none of the other factors would impact your campaigns, what would be the conversion you would have anyway? Obviously, it makes a lot of sense that if you are a mature company, you have been advertising for a while, if you switch off advertising today, you're not going to lose all of your sales right away. So marketing mix modeling is the only one of the technique that is telling you what the baseline actually is. Then you have your axis. This is a matrix of regressors. You can think of it as different columns, each one of which is representing one of the channels you're advertising on. Yeah, each row is gonna be a week, for example, and you're gonna look into signals such as impressions, cost, clicks, or whatever you're calculating for that channel. The Z's is going to be another matrix of regressors, different columns, which are going to include all of the control factors. It can be your seasonality, it can be pricing, it can be discounts. For example, a very simple way to take discounts into consideration is you just check the actual prices that people paid for your products or services divided by the face value prices. And that's the depth of discount. Yeah? By that number, you know at any point in time how big the discounts you gave to your customers were and how that impacts your total revenues and sales. And finally, this is very important to say, this is a probabilistic model. It's not a deterministic one, so you have an error too. Yeah? So that error is important to be there. You don't want to be overfitting your model. You're not going to be able to explain everything that goes on with your customer and the consumers at any point in time. So if you reach an accuracy of 60% to 80%, you're still doing well. If you go into an accuracy of 90%, I'm going to trust your model less because you're likely overfitting your model a bit. Yeah? So you're just making it such that you figure out how to, for the past, to have all of your factors explaining all of your sales, which is rather impossible to do. Yeah? But I see it often. The betas are also very important because these are the sensitivities of each one of these factors to the sales. The bigger the beta, the bigger the proportion which that specific factor or marketing channel impacts your sales. Yeah? Now we will give an example of how linear regression works, just to give you an idea, to make it simple for you. And you can also test it at home. The simplest way for you to test a marketing mix model is just to run linear regressions on Excel. At least you get, for a limited radius of possible results, you get an idea of how a channel is impacting your top sales. And then you can make it more sophisticated. We will listen to why.
Thanks, Enrico. So Enrico mentioned there that MMM has regression at the heart of its modeling. Let's have a quick look, a reminder on what linear regression does as a simple example. So here on the left, we have revenue plotted against a channel ad spend. So that might be our investment in meta ads. And each of these data points, as Enrico mentioned, is a week. So those are the rows in our data set. All regression analysis is doing is putting numbers to this collection of data points. So we're plotting a line here on the right, and that line's equation is y equals 3x plus 150. What does that mean? What do those terms mean? Well, the multiplier, the 3, means that revenue is positively correlated with our channel ad spend. So for every $1 of extra marketing spend, there is an extra $3 of revenue. That means we have a ROAS of 3. This intercept or offset, 150K, that means there would still be 150K revenue if we stopped advertising on this channel, if we set our ad spend to 0. So that could come from other channels or this idea of the baseline that Enrico mentioned. So anything else that contributes to our business's revenue. And there's also some randomness to the data. So you can see our model here, our line, doesn't perfectly explain the variation in revenue because there's error between the points and the line. So this could come again from other variables, like other channels, or it could come from that important error term that Enrico mentioned. We're never going to be able to explain every single variation in our revenue. Let's look at how MMM takes that a bit further, that idea. So we've just discussed linear regression. MMM is multivariate time series nonlinear regression. It's a bit of a mouthful, but we'll go through these terms. So multivariate regression just means that we're regressing multiple independent variables to our revenue, for example. So that means we're looking at the ad spend of multiple channels and other factors like promotions, seasonality, or offline marketing. All of these play in, and MMM is holistic, so it will try to regress your revenue to all of these different factors. Time series regression. So we've discussed that each data point on these charts is 1 week, so the data is already in a time series format. But another thing which is very cool about marketing mix modeling is that it has this idea of lag regression built into it. So we have this concept where the ad spend we spent last week or the week before that will impact the revenue that we record this week. That is a logical concept, right? And the cool thing about MMMs is that they have this concept built into them mathematically, and it will do regression on this week's revenue against last week's ad spend across different channels as well. And it is a non-linear regression. So we previously looked at linear regression, the most simple form on the previous slide, but this is too simplistic to describe the relationship between channel investments and revenue. Instead, we use these tried and tested econometric curves, like a hill function, and that describes this response curve shape that you see here on the right. That's what MMMs call them, response curves, and that describes the effect of diminishing returns or saturation that you get in your marketing ad spend. So the more money we put into a channel, the lower marginal returns we will get over time, and that is just a tried and tested econometric technique, and most good MMMs will have that built into them as well. So what does the output of an MMM look like? Well, at its heart, it's still an attribution model, so the outputs look very similar to what you might get from multi-touch attribution. You basically get your revenue share attributed or decomposed in MMM terms to different channels. So you can see the online channels here in blue, and then MMM is holistic, so we've included an offline channel for an example here, our TV activity, and also you get a decomposition to this idea of the baseline. So in this case, the baseline contains things like email or non-paid marketing, but it also includes this idea of like brand awareness or brand engagement, and you can split those terms out when you do an MMM, so you can see how much your email campaigns are contributing to your overall revenue, and then how much is left in terms of latent, unexplainable sort of brand awareness and brand engagement. So that's a really cool feature of MMMs. And in terms of acting on that, you can convert this to ROAS just like you would with a multi-touch attribution model. It's by dividing by your ad spends in the same time frame across each channel. And then you can make your budget planning optimizations based on the different ROAS of your campaigns. So it is also actionable for sure. Let's have a look at another cool feature of MMMs. So you can use a very flexible outcome variable with MMM. So whereas a multi-touch attribution model might just attribute your transaction value, or maybe have a clever custom one to do transaction profit or something like that, MMM will basically take anything you give it and try and decompose it between your input variables. So in this case, we had a client who was very interested in growth, so they wanted to find out which channel was driving their new customer revenue as opposed to their existing customer revenue. So we fit two separate independent MMMs on those two variables and found some really interesting results. PPC shopping was very incremental in acquiring new customers, so perhaps they would like to move some budget towards PPC shopping to acquire more new customers, and this was really interesting, but also kind of expected. The baseline was much bigger for existing customers. So that's because existing customers have much more latent brand awareness or brand engagement because they bought from the company before, and naturally they don't need so much paid marketing influence to make those buying decisions. So that was really cool to see that mathematically laid out when we fitted these MMMs. So again, I would not recommend building your own MMM from scratch. There are lots of open source packages available for you to do that if you want to have a go at fitting an MMM. We use Google's lightweight MMM as our base model at Careerlytics, and we add patches and tweaks on top of that model, but it's a great head start if you want to roll your own MMM. Plus points, it's a Bayesian model. I will come to why that's important when we talk more about triangulation. But you really want a more Bayesian model for triangulation if you want to use these lift test results. It has built-in ad stock and response curves, so you don't have to like define all of these econometrics curves when you're coding your MMM. It's already baked into the package, which is nice and convenient. We are looking forward to Google's Meridian. This is Google's new product that they've been talking about. It looks like Lightweight MMM 2.0. And it has some more advanced priors and more user-friendly interfaces than Lightweight MMM. So looking forward to that one. If you're looking for an alternative, Meta have their Robin solution, which is their open source MMM. It is frequentist, not Bayesian. I'll come to why that's important, but I don't think it's so suitable for triangulation as Google's Lightweight MMM, but it still has these built-in ad stock and response curves. So again, lots of options here if you are interested in using some data science resource to develop your own MMM for your business. In terms of whichever MMM you choose across those options, basically they all have the same requirements in terms of data, and it's actually very straightforward at the base level, and then you can iterate and add on top of that over time. So what data is required for an MMM? You will need your exposure signals by channel. So instead of ad spend, perhaps you want to use impressions or clicks or opens. I would recommend using impressions because they're probably the base signal from which people make their buying decisions. If you can't track impressions for a channel like TV or something like that, then you could model impressions using the reach values that you get from your TV campaigns. As long as you have some idea of rough estimate of impressions over time, you're pretty good. Time series of your outcome variable, so hopefully you will have this, your revenue by week over time, and again you can use very flexible variables for this, so like new customer generation, leads or downloads. As long as you can get those in a weekly time series format, you can plug that in and decompose it using an MMM. Optional extra covariates, so these are all the other factors that Enrico was talking about when we talked about that regression equation. So these are things like promotions, promotion intensity, your seasonal demand, which you could model from your non-paid sessions, for example, your competition intensity, anything that you think you can track, which might help explain variations in your business's revenue over time. That will help increase the accuracy of your marketing mix model. So that's something you can iterate over time and ingest more data into your model to improve the accuracy. And then finally, if you're using a Bayesian MMM and doing triangulation, you will want to have your prior distributions for that. And I'll talk about that more when we get to the triangulation section. So another few key learnings that I've put together with Enrico here from our combined experience fitting MMMs for different businesses. So this idea of a baseline, a healthy baseline for a mature business is usually between sort of 40 to 60%. This means if you stopped all your paid marketing today, your business would be okay for a while and survive running on that 40 to 60% baseline. Promotions can have a real catalytic effect on your marketing. So if you're using your marketing channels to market your promotions, when we ingest that into the MMM, you can really see this boost in the decomposition for those channels when the promotions are happening, up to sort of 2 to 3 times the contribution sometimes. And again, as a rule of thumb, this is a probabilistic model. There's also some signal to noise issues. If you're trying to do really small campaigns or channels, MMM will probably be most effective for your larger channels that have maybe more of a budget share of more than 5%. But to get down to campaign level or lower, you might want to go back to multi-touch attribution, which is what Enrico will talk about in our next section.
2 methodologies down. How are we doing? Still okay? Here's the deal. I'm going to take you through MTA at light speed, so then we finally get to triangulation at the end. Sounds good? All right, MTA. I'm also going to take you at light speed in MTA because it's a methodology we like the least. We'll tell you why. So the methodology is about understanding what's the value of each touch point within a conversion path of the user. You know? How does each channel contribute? It's a user level type of methodology, bottom up. The reason why we like it less is because it's very, very myopic. It only sees your visits, your traffic. It doesn't take into consideration everything else that is going on with your campaign. So the minute you start investing money in TV or radio or something else that it's not digital, it's not going to help you much. And also, you know, like when you run Facebook ads, YouTube ads, video views, engagement on your social media ads plays an important role. Yeah, multi-touch attribution doesn't see any of that. Here are the several approaches to multi-touch attribution that most of you already know. You have the rule-based approaches, like last touch. You only give credit to the last channel in the conversion path. You have the first touch. The first channel gets credit, nothing else. You have the linear, where you're assigning credit equally to every step in the conversion chain. Then you have time decay, where you're using a so-called lambda function, which is giving more value to the recent touch points and less value to the less recent ones. And then a very popular one is the U-shape model, where you're giving big value to the first touch point, big value to the last, and then everything else in between. Typically, I still see some companies do a 40-20-40, where you're giving 40% of value to the first touch point, 40% to the last, and 20% divided in between. But really, the industry is moving towards a data-driven type of attribution. How does it work? Very simple. You take user-level paths, you look into the paths which differ only by a touch point, you calculate the probability to convert, which is, by the way, your empirical conversion rate is also your probability to convert. Very simple. You look at the difference between the two, and then by that, you realize what's the uplift between one touch point being part of that path or not. There are a lot of different algorithms you can check, from game theory, from science. You have the Shapley value, which is what Google uses. You have the Markov chains. You have the LSTM neural networks. You have many, many different things. And we will share with you some papers that you can read about them if you're interested. Here's why we don't like it very much. Because if you think about a real user journey, it can be like the user journey you see on top. Someone is watching an ad on TV, then is clicking on a Google ad on their desktop computer, then finally watching a video on Facebook, and then converting. What your MTA is going to see is only the click on Google. That's all, nothing else. That's why, this is highly myopic. You don't see the offline marketing channels. You don't see impressions and video as engagement touch points. You don't really check cross-device, or at least you check cross-device, but only probabilistic, depending on how many connected devices you have and how you're logged into multiple different platforms. So you need to be careful when you look into MTA results. Yeah, you might draw the wrong conclusions if you only use that. Many ask me, oh, what is the real difference between MMM and TA? I'm confused. I don't really understand. Well, here's the thing. So the approaches are different. One of the approaches, MMM, is top-down. You're comparing the inputs with your outputs. The other approach is bottom-up. You're looking at user-level data, conversion paths, and then you aggregate them to understand what's the difference between the touch points and how each contributes. The scope is very different. As we said, MMM is holistic. You're looking into every factor, offline marketing campaigns too, and you're also looking into control factors such as seasonality or discounts or pricing, or you name it. The granularity is very different because MTA is on a user level. You're able to check the granularity, to check how your attribution, even at ad level, keyword level, whatever you like. You can't do that on MMM because MMM is looking at correlation. So if your signal is not strong enough to impact your top line, you're not going to be able to detect it. Yeah, so you need the two to work together. So the timing is also very important. Yeah, MMM, you can't do it on a daily basis. You need to calibrate it. It's a big model. Yeah, and it's also the type of stakeholders that are using MMM and looking at the MMM results are very different typically from the MTA ones. If you are a media buyer, if you buy ads on a daily basis, you rather look into MTA because you need to make quick decisions. But if you're a stakeholder who's doing media planning and media allocation, you want to look at the MMM results. And privacy, yeah, future-proof. The first methodology, MMM, is future-proof because it doesn't depend on cookies. The second one, it's highly reliant on cookies. So with consent management and so on, it makes it difficult to understand. How do you get started? Well, every platform is already doing some sort of attribution. You're already doing it on a daily basis. Yeah, on Google Analytics is typically your holistic point of view, where you're looking at how all the different conversions get together into the different touch points for a conversion path. You can get a data-driven attribution model already built in. Yeah. Problem is, it looks into visits only, so it just misses a big portion of the picture. On Meta, you have a last touch attribution model. If you have a click, it's going to look into the last click. If you don't have any click, it's going to look at the last impression. On Google Ads, you can enable a data-driven model. Many of you can do that within the platform. Just remember that the scope is only the Google properties. Same thing with Meta. The scope is only the Meta properties. Yeah, and you also have a different attribution window, and you have different cross-device tracking capabilities. Cross-device tracking capabilities from Meta are incredible. Why? Because you need to be logged in. To see an ad from Meta, you need to be logged in. So he always knows, Meta always knows it's you, from your mobile phone to your desktop to any other device. That's really powerful. So don't discard the Facebook Pixel because it's a very, very powerful one for cross-device. Here's the thing, MTA is still indispensable for intra-platform tracking. There's no way around it. If you want to make sound decisions on which ads to push, which audiences to double down on, which campaigns to invest on, you still need MTA. There's no other way. But you can trust those results only on a relative basis. If you look at a CPA or acquisition cost on one of these platforms, don't take it as your absolute acquisition cost. It's probably not that. But on a directional basis, you can see whether you're becoming more and more efficient over time if your CPA goes down. And you can always check whether that channel is correlated to your total sales. So you can do some sanity check on a MMM side, even if you don't have the MMM capabilities, with means of a simple linear regression. Yeah? And your absolute truths instead are your cross-platform MMM. Yeah? We will see how these two things work together when it comes to triangulation. Many think that data-driven attribution is going to go away with third-party cookies going away. But that's not true. I mean, it's still going to stay. There's still going to be a way for you to be able to see, to see the touch points. Maybe you as an advertiser won't have access to the single user level paths, but definitely your platform will be able to still see it by means of UTM parameters and checking how a progression works on first-party cookies. Yeah. And there's also, you see it, you see enhanced conversion, you see the conversion API solution from Meta, you see enhanced conversion from Google. You still have a way for you to link the person that you served an ad to with the person who made a conversion at the very end by means of using the email addresses, for example, the hashed email addresses. So that's a way for you to do some sort of server-side tracking. Yeah. Here, as I promised, I took you quite quickly into this. I think. Okay, some learnings from that. So MTA, however you put it, however you change it, unless you drastically change the idea, is still very biased to bottom of funnel results. No way around. Most paths, when you're only looking into visits, are actually not so complex for the majority part. If you actually look into this, if you look into Google Analytics at the paths, you will see that 50% of them include a couple of touch points maximum. No? If you just take that analysis, which is already built in, you will be able to see that. And also MTAs are not, they don't capture incrementality. You will still see a lot of attribution on brand keywords, on retargeting, because they are very correlated to the paths where you have a sale at the end. Well, I'm not surprised, That's why, yeah, that's why this methodology is a little bit, tricky. Yeah, still important. You need it for granularity. But now we finally get to triangulation. Yeah. So how do you do all of these three things together? Yeah. Now we have three methodologies. They give us different answers. We have to put them together. The process is the following. You start with a Bayesian marketing mix model. We will see why Bayesian and not frequentist in a moment. You then take the results from your experiment. You inject them inside the MMM model, the Bayesian one, to recalibrate the results. So the idea is that you take your prior knowledge of your business by means of running experiments, because you know that you establish causality with those. You use those and you inject those results inside your MMM. So your marketing mix model is going to look at your prior knowledge, it's going to look at the evidence as data, and it's going to bring them together into a single answer. And then finally, what you do is you take the MTA results and you attach them underneath. So then from your top level insights, you're going to be able to go down to a granular level. Yeah? Tell us more about how this works in practice.
Thanks, Enrico. So coming back to our idea of doing a standalone marketing mix model, I think you can already get semi-realistic results by just running an MMM, as long as you take care on which covariates to include, etc. Mainly because it has this idea of the baseline, which multi-touch attribution doesn't have, and I think that already gives MMM a sense of realism versus multi-touch attribution. But we can increase this realism and make sure that our MMM is based in reality by including geolift or incrementality test results as prior distributions for that model. So let's have a look at what I mean by prior distribution. So MMM as I just mentioned, is correlative. It works on regression. It can still make mistakes and produce fairly unrealistic.
Can you still hear?
Can you still hear me?
Let's wait a moment.
Yeah.
Okay.
It can still make mistakes and can produce some unrealistic attribution because it's just a regression probabilistic model. So we're ingesting these incrementality tests as prior distributions to this Bayesian model, and this ensures that the real life results means that our MMM output is always based in reality. So we're setting realistic bounds to the possible outputs from our MMM. Let's have a look at how that works in theory. So we've talked about this idea of Bayesian modeling. So there are two schools of statistics. You have Bayesian and frequentist. Frequentist is probably what most of us learn in school. It's very data-driven. Bayesian is a bit more of a recent school of statistics, and it involves this idea of prior distribution. So you can ingest your prior beliefs into a model and set realistic bounds for the outputs of that model. So the idea is that in a Bayesian model, nothing is a fixed point estimate. Everything is a distribution. So every parameter in that regression equation that we looked at earlier in a Bayesian model is actually a distribution, a range of values with different probabilities. And what you can do then is inject your prior beliefs. So normally the model will just be producing those ranges of values through its regression optimization. But what you can do with a Bayesian model is say, hey, I did a test in this channel and I got this confidence interval, this range of values from that real life experiment. Please take that into account when you're doing your regression optimization. And a Bayesian MMM will do that for you. And that means that it can't produce unrealistic results. The results will in some way be related to what you've ingested as your priors, your real life experimental results. So let's have a look at an example of that. So we've fitted an MMM here with no prior ingestion, and it's come out with the result that paid social acquisition contributes 12% of our online or business's revenue, and remarketing in paid social contributes 6% of our revenue. But we know that this isn't quite true because we've done this split incrementality test that I talked about before in this market, and we know that paid social acquisition actually contributes 20% of our business's revenue, and we know that remarketing is actually lower than what this model is saying. Remarketing only contributes 3% of our business's revenue. So we can ingest those as prior beliefs into our Bayesian MMM, and that will adjust our results because the MMM will keep that in mind as it's doing its regression. So we can see the result of that here on the right. It's boosted paid social acquisition to be 18% contribution, which is somewhere between the 12% from the default MMM and our lift test result, and it's attenuated the share of remarketing in its revenue decomposition based on our lift test results, saying that it's much lower than what the MMM was previously attributing to that channel. So this works in practice, and this is how you can achieve realistic, holistic results for digital marketing measurement at your channel level. So this already gets us most of the way in terms of planning for the future, doing our budget planning. We can be confident in these results at a channel level because we've done these tests on our larger channels. We're not quite there though. We still need to steer the present, as Enrico mentioned earlier. So we have these realistic results at a channel level, but an MMM and also lift tests aren't quite granular enough to get down to campaigns, ads, keywords, any of these low-level entities, and they can't answer questions like, within my PPC shopping campaigns, which product category is performing the best, or which ad creative performs best, which operational digital marketing teams need to know to steer their ads and move budget inside a channel. So how do we tackle this problem? We have to go back to our old friend, multi-touch attribution, to get down to that level, and that's how we do this. It's a very simple approach. On the next slide, we take our realistic channel level results and we basically do our multi-touch attribution within each channel. It doesn't really matter what multi-touch attribution model you're using. You could be using a custom one or Google Analytics 4 or even the in-channel attributions at a push. As long as you can get some relative results within each channel of which campaign or ad or keyword is producing value. So all we do is take these relative results in the middle and scale those by weight to the total revenue that is attributed to each channel by the MMM. So we know we've got realistic results at a channel level. We use multi-touch attribution to get the weights for different campaigns within each channel, and we just scale them to make sure that when we add up to that channel aggregation, everything adds up to what the MMM says. So it's actually quite a straightforward approach, and we keep this idea of the baseline, and we keep our offline channels, our holisticness of an MMM, but we've now got realistic channel level results and granular results where we can make real-time granular decisions, and we are using the best of these three marketing techniques together, doing what we call triangulation to do that.
And now we have a really dense page, yeah? So don't read everything in it, I'm gonna walk you through. So there's a lot of things you need to configure and you think about when you wanna make it in practice, yeah? So first of all, you need to think about your target variable. What are you gonna use? Are you gonna measure sales? Are you gonna measure new customer, app downloads, whatever? Our recommendation here is if you have a chance, run multiple models because they're gonna give you different answers and different interesting insights on what each channel contribute to that specific metric. The second thing is we get a question often on what marketing channel should you include? Only the big ones, also the small ones, the offline, digital, include all of them. This is supposed to be a holistic model. Unfortunately, for the channels where you spend little money, you're not gonna be able to trust the results completely because at the end of the day, you don't have enough, signal to be able to be, bigger than the noise you actually have on the model. But still, it's important that you include everything because the more you include, the more variability in sales you're gonna be able to explain. Control factors, yeah? Here, different answer. How many control factors to use? Use only the main important ones because you could get into a rabbit hole very quickly in trying to explain everything that happens in the world that is impacting the consumers when making a decision to buy a product. I think, remember what this is. This is a marketing mix model. It's not it's not a model that is trying to explain everything that happens with your consumers. You want to use this model to be able to understand what's the value of your marketing channel on your final. Only use the control factors which make sense to you. Also remember, they need to be quantified on a weekly basis, which is not easy to do. For example, what's the competitive pressure like? It's very difficult to quantify your competitive pressure on a weekly basis because typically you don't have access to the budget that your competitor is spending on a weekly basis. You don't have numbers that you can really quantify. So you need to be careful in deciding what to include and what not. You need to define the exposure signal. Am I gonna use impression, span, click? What do I use? Typically, our recommendation is to use the one metric which is homogeneous across the different channels. And the one thing that you can find for most channels is impressions. So that's a good quantity to use in order to run your marketing mix model with triangulation. Finally, you also need to take into consideration special events. If something specific happens, you had a funnel break, you had something happening with your website, you launch a new product, something that changes completely your results. You want a model for that. So the marketing mix model is going to know that something specific happened in a specific period of time. How do you do it? You use a dummy variable. You give the value 1 to the weeks where that happened and 0 otherwise. So the model will know that something happened in that specific point of time that explains some peak or decrease in sales. You also have 3 important things that you want to treat statistically. As we said before, it's the prior knowledge. The prior knowledge is typically modeled as a gamma distribution, it's a parametric distribution with a standard deviation and a mean that is going to explain what ranges can your sensitivities, your betas take. Yeah, and with the models with the libraries that Stephen shared before, you can take those into consideration. It's already built in. It's pretty important. Long-term effects of marketing, that's also important. Not every channel is equal in that sense. When you invest money in TV, for example, you have a way larger typically lag effect versus if you spend money on a channel like paid search. How do you model that? You model that with the so-called ad stock. Ad stock is a variable that is telling you how much long tail effect you have on a given channel spend for generating sales or your target objective. The final one is very important too. Remember, Yeah, your marketing budget has diminishing returns. Yeah, you can't achieve the same ROAS if you double your budget, most likely. So you need to take into consideration this logarithmic type of function and firm that your budget spend as, when it comes to your ROAS and your return on investment. How do you do that? You do that with either these logarithmic functions, the yield functions. There are multiple ways, but typically those packages you use, they're going to tell you how to do this step by step.
Thanks, Enrico. So if you're interested in building or running any of these solutions yourself, you will need to invest in some data collection. So you will need, for lift testing, your site revenue or whichever variable you want to measure the impact of at a sort of city or region level in all of your core markets. If you want to run tests in those markets, you need to be tracking that. And then you generally want to try and get ad spend on a similar level, and that will enable you to calculate the ROAS that you got from that test, by which ad spend you saved doing a holdout versus how much revenue you lost, that kind of thing. If you're interested in doing a marketing mix model, we've found the best performance of our models if we have around 2 years worth of data. 100 plus weeks gives the best accuracy that we've seen. If you don't have that history, maybe you don't even have that history in your business, by all means try and just plug in the data that you have, and that will improve over time as you build up seasonality as well. You want to ingest those exposure signals that we talked about, generally impressions, your outcome variable, whichever variable you're interested in decomposing as well, and then these other covariates, so promotions, non-paid sessions, competition over time. If you're interested in rolling your own custom multi-touch attribution, you will want to use a reliable tracking pixel. You need to track sessions and you need to track transactions, and that will allow you to construct customer journeys in your time series. And then you'll need some kind of click ID mapping from those touch points up to whichever aggregate level you want to view your reports on. So you'll need to map your multi-touch attribution up to campaigns, for example. Then you need some resource if you want to build these solutions. So you'll definitely need some kind of tech resource. You need a data warehouse in which to store this data. You generally want some API connections to continuously pull this data into your data warehouse. You will need some cloud infrastructure, some cloud machines to host that API pulling infrastructure, as well as your pipelines. So if you're fitting an MMM and you want sort of weekly outputs, you generally want to run that on something like Airflow or Kubeflow, which will run on a scheduled basis. And you'll want a dashboarding tool, so like Tableau, Looker, or Power BI, where you can view these reports and make your digital marketing or budgeting decisions. You'll definitely need some skill sets if you want to build these solutions. So you'll need some data engineers to look after your data warehouse and maintain your pipelines. You will need probably some data science resource to design your MMM and make sure it's suitable for your business, because you can get very custom with MMM. And of course, if you want to design and evaluate geo experiments, that generally requires some data science as well. And then you'll need your marketing analysts to interpret these results, make decisions, and make recommendations to your budget planning decision makers. All of these take some time. So each geo experiment project we do at Crealytics, we tend to spend sort of 6 to 8 weeks on each project. If you're doing your first year experiment, it will probably take you a bit longer than that to get used to the packages and designing and evaluating experiments there. If you're building an MMM, this can be a long project, a really huge undertaking. So this can take months to years, depending on the maturity of your business's data, the complexity of the model, and which resources you have available. And the same goes for multi-touch attribution. So this can be sort of a weeks to month long project, depending on how complex you want that algorithm to be. That might sound daunting. Obviously, if you're not feeling comfortable with building these solutions, you can buy instead. There are many providers that can help you with any of these solutions. At Crealytics, we help our clients with these problems every day and have sort of depth of experience in each of these solutions, but also this idea of joining them together with Triangulation. So if you wanted to get in touch, please just get in touch after the masterclass. That would be great.
Yeah,
Thanks.
indeed. There's a lot of way to go about it. I know by running some of these models internally with teams, you tend to underestimate the effort that it goes into it and how many iterations you have to go through. But it's typically a quite a big project. But you finally can get to some sort of a single source of truth. Who now believes the single source of truth is possible after this masterclass? Any optimist? Ooh, few, very, very few. Thank you for those who believe that. Well, why we need triangulation? Well, if we go back to what we said at the beginning, it actually fulfills the three. You know, it says four, but it actually three marketer needs. You know, you want to, with the when it comes to understanding the past, you have MMM, which allows you to look into the past results and make a sense of it. You also have MTA, which on a relative basis tell you what the past is. You have optimization. You can steer the present thanks to the leaf testing, because you're running a leaf testing right now and you can check how these perform and then make sound decisions. And you also have the MTA that allows you to do that. And when it comes to strategy and plan the future, then of course the MMM part of it will allow you to take sound budget allocation decisions. So triangulation as a whole fulfills all of your marketer needs. Yeah, we want to thank you so much for spending time with us, for the resilience of going through 3/4 methodologies and some technical things. We appreciate you very much. Here we have a present for you. So if you look at the QR code here, there's going to be a link tree with a lot of information and documentation that you can read if you're interested in expanding your knowledge on the topic. And feel free to connect with us. You also have our LinkedIn QR codes. Now we will still have time for a few questions. And yeah, thank you again.
Thanks, everyone. Some small tech setup.
Okay, can you hear me? Is it working? Yes.
Thank you. Hi, I'm Arne. Does it work now?
Yeah.
Perfect.
Yeah, we can hear you.
Sorry. Doesn't go over speaker, so that's a bit weird. Thanks a lot for the great talk, super insightful. Two questions to the way you approach triangulation. When you think about the lift studies and the MMMs, you once recommended or said that you prefer the Meta option and the Google option. Is it easier, user-friendly to go with one of them, at least to get started, and what will be criteria to decide for which route to take? And second question on lift studies in particular, when you do it in triangulation, you mentioned these two examples. For the paid social options, would you need to do lift studies across much broader range, or is it sufficient to pick out two? Thanks a lot.
Sure, great question. So I'll start with the second one, perhaps. You should aim to test all of your biggest channels, I think. And if you can do GeoLift or another incrementality test style across your 2 or 3 biggest channels, then you're already in great standing for ingesting those results into your MMM. Back to the first question, using the open source libraries, at Crealytics we're agnostic as to which big tech companies open source libraries we use. We've tried out all the different ones. So there's GeoLift from Meta, Trimmed Match from Google. I happen to find GeoLift a bit more modern and user-friendly. And in terms of the MMM, it's just Robin is frequentist, not Bayesian. So we're not using that for triangulation because it's slightly less suitable. I don't think there is a great advantage to sticking with one company's open source libraries. You can kind of mix and match them. So I know there are a couple of white papers Meta have produced where they will take GeoLift and try and ingest those results into Robin, even though it's frequentist. But I don't think there's a great advantage to sticking with one big tech development team in terms of open source libraries. You could just use the one that's most user-friendly or suitable for your business, and then use the other one for the MMM. We can interchange them. Thanks.
Yes, thank you for your talk. We have the issue with our multimedia mix model that we can't differentiate that much, for example, for paid media or Google Shopping or whatever that has a high correlation to the click and to the interaction with the user, compared to the TV media, for example, where you have this kind of media break in between, and even the ad stock that we use for modeling can't close this gap. So, are there any ideas from you to mitigate that? Thank you.
Look, I mean, you bring up a very, very important problem, which is when you do always-on campaigns, those always-on campaigns, especially if you spend the same amount of budget over time, they're not going to be helpful when explaining the variability of your sales. So here we recommend actually lift testing. Yeah, if you have a chance, you can do the lift testing, so you know that if you turn off partially part of that budget on that specific channel, you're going to be able to see what's the results on sales, on top-level sales. That's the only way around it. Because unfortunately, one of the disadvantages of MMM is that they are based on correlations. And therefore, if you have they need variability. If you have the same amount to spend over time, you're not going to be able to see what's the impact on your top line. Yeah? So that's why you need the lift tests. Anything to add?
Maybe just a small thing to add. If you're struggling to do a lift test for a channel like TV, because you can't do sort of geo splits on that channel, what you could look into is a causal impact analysis or it's called a discontinuity analysis, and you basically try and use a covariate like your natural search demand or something like that, and you do a causal impact analysis on that marketing activity and try and measure the bump on your overall revenue from running a TV campaign. Hopefully that's possible.
So what do you mean with that, for example, like the brand keyword in Google Trends, for example?
Yeah, so you can look at your brand search volume, or you could look at your simple like direct sessions to your website, and this gives a great covariate of your general online demand. Yeah.
Great question, thank you.
Thanks a lot. Great presentation. I have two tactical questions. First, for geo-testing in some countries like United Kingdom can be tricky as London can be an outlier. So do you have any tips for the countries like this one? And second is for the channels that rely heavily on impressions like TikTok, where click is non-existent. What is the alternative to MTA to optimize for the creative?
Yeah, that's a great question. So tackling the first one, London is a massive pain always when doing geo experiments in the UK. We just cut out London every time. Unfortunately, that does mean that any results that you get from other cities in the UK, you're kind of taking a risk by extrapolating that result to London, right? Because it's like its own country. But this is just an unsolvable problem, at least in my experience, and you just have to take that risk and make that jump. So we do geo-testing on like other collections of cities in the UK and then extrapolate that to the market. The second question about TikTok, impressions-led channels, I can definitely see that being challenging if you're using a multi-touch attribution model. So what I might suggest is to just, presumably there's an attribution model inside TikTok, and hopefully that is view through. So if you can use that to give some kind of directionality to which campaigns are performing best inside TikTok, and making sure that on the channel level you have some hopefully non-multi-touch attribution way of measuring the channel's impact overall, then hopefully you can use that in-channel attribution to steer in the present, and then another solution to your budget planning. Yeah, great question.
We have time for one more, maybe?
I thank you very much for the presentation. I have a practical question on ingesting the lift studies into the MMM. I am not sure I understand how it works in terms of, so from the model point of view, because normally the metrics that we ingest is GRPs, impressions, spends, and so on. But here you are talking about integrating a finding from another test into the model. So I just wonder how should it look like in terms of metrics?
Yeah, a great question. So the priors that you ingest into an MMM are kind of orthogonal to the input variables that you have over time. So the priors are actually on the betas, so they're the beta coefficients that you ingest, and you tell the MMM, so in lightweight MMM, there is just a function to do that, and you say, consider this prior distribution. It's like a SciPy distribution that you create, and you give that to the model, and you say, for this beta coefficient, like the Facebook, the beta for the Facebook term, you would say, I know that Facebook contributes around this much of my revenue because I did this lift test, and we actually patched lightweight MMM to use gamma distributions as priors to do that. So by default, they're doing half normal distributions, which aren't as suitable. So we've patched that to better represent a geolift result. And then we can ingest that prior distribution for it to consider during its regression optimization. So that's how we do it.
Remember, when we looked at that, when we took you to school for a moment, we were looking at the equation. The whole idea is that in frequentist statistics, it's the X that is random, the data you give. The parameters is fixed, and then thanks to the data you receive, the better the data, the closer you're going to get to the real parameters. Here, in Bayesian statistics, the beta is actually a distribution. It's a gamma distribution of values, which becomes better and better and skewed and closer to the mean with a lighter long tail, the more data you have, the more knowledge based on evidence you get on data. That's the idea. If you use one of those libraries like lightweight MMM, they're going to give you access to the gamma distribution by itself, and all you need to set up is the means and the variance of that distribution for each of the parameters. That's how you define your probability function.
Yeah, that was a great answer. And just to add to that, you can't only, it's not just incrementality test results that you can ingest as priors. Maybe you just have a hunch about a channel, or perhaps you generate some priors from something like a post-purchase survey. There are lots of methods for generating these hunches or priors that you can ingest into a Bayesian MMM, and all of those will be helpful in getting your results at a realistic channel level. Yeah.
Thank you very much.
Thank you again.
Thanks, everyone. Thanks for joining the talk.